Hey guys, in the first big update to the simulation, I've added a day-night cycle, which was suggested on Pateron by universe.guy. I've expanded upon the rivers and lakes, making them a bit more realistic and allowing animals to specialise living within them. Added a few animations to hopefully make it a bit more clearer of what the animals are getting up to, and a few bug fixes here and there. And we begin our journey at the origin of life itself. The simulation assumes that it started around these volcanoes. For now, it's feeding off the volcanoes themselves. However, some organisms take advantage of the plentiful sunlight and become more and more photosynthetic. After a certain point, they can live independent of the volcanoes and become freely floating organisms, allowing them to spread far and wide. The algae is also affected by the day-night cycle. They stay still during the day, during which they photosynthesize, while moving and reproducing at night. The algae can also evolve to live on land, where it's sufficiently moist. They can begin evolving into moss, and eventually the first plants. The world we're simulating is made up of a continent and a small island you can see just off its coast. A shallow inland sea separates the two of them, with two small oceans on either side of the shallow sea. At the top of this hill, we can see what looks to be beginnings of a flow channel. The moss can only survive in very moist environments, and so they roughly outline the path the water takes from the top of the hill to the bottom. These clouds are evaporating off the surface of the ocean itself, and they're being pushed towards the hill by wind currents. As more and more moss, and eventually plants, evolve, grow and respire, they'll add further moisture to the atmosphere, resulting in a lot more clouds and a lot more rain. Allowing some time to pass, we can see the moss, which is still present in the background, has evolved into the first simple plants. The colour of the plants' trunks are representative of their genetic difference to those around them. These plants are very simple. Having yet to evolve proper leaves, they photosynthesize through their green branches. They reproduce through the use of pollen and seeds, which are the small orbs you see around them. Pollen, the smaller of the orbs, move around randomly until they reach a suitable plant. They then pollinate the plant, which then produces a seed, which will also move around randomly to reach a suitable area and germinates. But the fight for light is universal. Early plants on both islands have grown taller and taller in response. Heavy rainfall across the small island has led to it being dotted with standing bodies of water. Here, algae have an advantage, as the water can drown the more complex plants. And while all this was going on, the animals have gotten a firm grip over the oceans. There are a few false starts, but it seems like these guys will survive. When the animal moves its legs and tail, this means that it's found something of interest that it wants to move towards. This can be either food, an unfertilized egg, or a member of its species it wants to herd with. When the animal moves its head up and down in size, that means it's currently eating something, and when it closes its eyes, that means it's asleep or blinking. Now while these animals may seem to have made the leap onto land, you may have noticed they're not actually getting anywhere. This is because these animals can't truly traverse on land just yet. When there was flooding, they swam up over the land to feed on the plants. Now that the water has receded again, they're now stranded. However, it's adapting to make the most of this process, which will eventually lead to the true first land animals. Allowing a bit more time to pass, we can see that life has made further inroads into the continent. Though the animals and plants may look pretty similar to the animals and plants we saw before, that's largely superficial. The plants have evolved better capabilities at retaining and reducing water loss, and the animals have evolved stronger limbs to be able to move more efficiently over dry land. As the plants continue to develop and respire, we can see there's a lot more clouds in the sky, which has led to a lot more rain, and the volume of water flowing down the river we saw earlier is now much higher, and we can begin to see where a more stable river will eventually form. Meanwhile, in the shallow sea, we can see the animals have become quite large. Some of these animals are still adapted purely for an oceanic life, but some of them have evolved to be semi-aquatic instead. And though we can see slight variations in when different species go to sleep, it still seems to be largely the same. In contrast to the plants growing near the coast, the plants up on high altitudes have remained short. This is due to the extreme weather found up here. Some of these high altitude plants have gone far enough inland to find new low ground. Now, no longer being constrained by extreme weather conditions found at high altitudes, it's now their time to grow tall. Going back to the small island, we can now see that those semi-aquatic animals have now completely overrun the island. We can clearly see the effect the terrain has on the environment. With this hill casting a rain shadow on the side facing away from the ocean, we can see it's much drier and practically devoid of life. Between the two hills, we find this depression. While it's bone dry right now, I'm hoping that as the ecosystems mature, produce a lot more moisture through rain, the whole valley will flood, and we can get a nice lake. And sure enough, allowing a bit of time to pass, the lake seems to be filling up. In fact, the outpouring from that lake was even able to feed a second lake lower down. Taking a closer look at the lower lake, we can see how some of the animals have become semi-aquatic, with more streamlined bodies and even a tail fin. As time goes on, we can see the animals become bulkier. This allows them to have larger guts, which is more efficient at digesting plant matter. And the pink-headed animals are doing really well, not just on the mainland, but they're also dominating the small island. While the lakes provide food and a new habitat for life to exist in, it can also be a barrier, as can be seen by the two different communities of plants and animals on either side of the lake. As the algae has to come either from the sea or from moss regressing back to an algal state, not all bodies of water have algae. And here's another instance of flooding causing sea animals to come up onto land and then getting stranded. Here we can see how the rainwater from the hills forms a river which fills the lower lake. And the river that flows out of the lake into the oceans. We can now see the animals have become considerably larger on land. However, in the lake, where resources are more limited, we can see they've still remained relatively small. Though the animals in the highlands have become considerably larger, they aren't much taller. This is because the plants they feed on have also not become much taller. The animals browse most efficiently when they're the same height as the plant they're browsing on. The plants have become the tallest in the coastal forests. However, there is a shorter understory of larger leaf plants, and this is the plants that the animals have seemed to have adapted to eat. However, just to the corner of this forest is where the largest animals in this simulation currently live. They have very long legs, which allow them to eat from the top of these trees. Interestingly, the only place that never developed its own large animals is the small island. This could be a case of island dwarfism, given the limited resources. Thanks for watching until the end. As always, please comment down below any thoughts you have. I really enjoy reading all your comments. You can support me on Patreon and subscribe if you're new, and I hope to see you in the next video.